This video is an introduction to the last section of Chapter 6. It's called Sinusoidal Models. A sinusoidal model can refer to either a sine or a cosine graph and is used to model things that go up and down in a repeating pattern, like high and low tide at the beach, like a person's height on a Ferris wheel. This is the famous Ferris wheel at Navy Pier in Chicago. Or like the times of sunrise and sunset each day over the year. Now, we know from our experience with creating models for data that the more data points you have, the better. But with sinusoidal models, you can actually get an idea of what should be happening if you have just 2 points, one maximum and one minimum, or one peak and one valley. Most of the sinusoidal modeling problems that we do will be in a context, like a Ferris wheel or modeling high and low tide. But to start, I wanted to do one example that just uses 2 ordered pairs with no situation. The very first thing you're going to want to do is draw a very rough graph that shows the 2 points that are given. Notice mine is not to scale, but it shows what we need. Next, I connected these 2 points with a curve that would show what it would look like if the first one was a max and then it went down to a min on a sine or a cosine wave. Next, since we know that from a maximum to a minimum on a sine and cosine wave is just half of a period, I really wanted to see what a whole period looked like. So I used the dotted purple line to extend to see more of my wave, and I went up to the next maximum, which is where the period would end. The reason I did this was to show one full period. Now, from that whole shape, I can see that that's the shape of a positive cosine graph because it starts at a mountain. And also because that first point in the period is at the x value 36, I know that I'm going to need a phase shift right 36. That little picture we drew gave us our phase shift and the type of function and whether it was reflected or not. Now we just need to find the period, midline, and amplitude. The next thing I'm going to do is find the period. Since the distance between the x values of the 2 points was 13, so 13 from 36 to 49, and I know that that's half a period, I know that I need 13 more to get to my next point. 13 after 49 is x equals 62. So that top point is 62, 12, since 12 was the y value of our original max. Also, since 13 is half the period, that means the whole period is 2 times 13, or 26. To find my b value, since we're working in radians, I said that my b is 2 pi over the period. 2 pi over 26 is pi over 13. Next, I need to find my midline. I drew it in as a dotted blue line on my picture, and that's going to be basically whatever number is right between the max and the min, 12 and 1. So to find that number, I find the average. I add the y values and divide by 2. 12 plus 1 is 13. Divide by 2, you get 6.5. Last, I need to find the amplitude, which we know is the distance from the midline to a peak or a valley. So what I did was I went from 12 to 6.5. 12 minus 6.5 is 5.5. That's also the distance from 6.5 down to 1. Last thing you want to do is put it all together. So I took my positive cosine shape, the fact that I had a phase shift right 36, my b value of pi over 13, my amplitude of 5.5, and my midline of 6.5 to get y equals 5.5 cosine pi over 13, in parentheses your phase shift, x minus 36, the minus is in the opposite direction, and then finally that plus 6.5 at the end. Now it's your turn to try some of these on your own.